Hi folks, welcome to Astronomy Live. Tonight I'm going to be talking all about the orbits of the planets and discussing some claims that have been made recently by Higher Truth Channel. So first up, before we get into it tonight, you might notice my desk here looks a little bit different. Instead of a joystick, I've got this giant lamp here. This is a recent addition to what I consider my space memorabilia collection. It was actually the lamp of Donald Buchanan, who was one of the lead designers of the Crawler Transporter. So the Crawler Transporter, for those of you who don't know, was this giant thing behind these guys here. This carried all the Apollo moon rockets and all the space shuttles out to the launch pad before launch. Donald Buchanan is the guy you see here in the middle, right here where my mouse cursor is. And the Crawler Transporter is this giant thing down here. And this massive platform on top of it is the mobile launch platform, which provided services to the spacecraft that it was carrying, in this case, the space shuttle. The Crawler Transporter also carried the Apollo moon rockets, and it recently underwent updates and upgrades so that one day it will be able to carry heavy lift rockets to the launch pads again, or at least to launch pad 39B. And hopefully the SLS rocket will be getting off the ground in about a year or two. And when that happens, the Crawler Transporter will carry it to the launch pad. So the lamp here was once the lamp that belonged to Donald Buchanan, and he helped design that Crawler Transporter right underneath this lamp at one time. So it's kind of a very small part of history, but I think it's kind of interesting to think that something that's so vital to the entire history of the space program, all the way from Apollo up through Shuttle, was designed in part underneath this lamp. So tonight we're going to be going over some calculations of the orbits of the planets and discussing, as I said, claims that have been made recently by Higher Truth Channel that things are not what they should be. So let's take a look at his video and hear what he has to say and see if we can't figure out what's really going on. So this is Higher Truth Channel's video, Are the Planets Being Disturbed by Planet 9X? And actually, I forgot. I need to switch my audio source here so that you guys can hear it.
Now these tables are reproduced every year for some reason, and the reasons we're getting is because of perturbations of the planets. I swear to God, it says right there, perturbations.
Okay, so bear with me as I switch audio sources back and forth between my microphone and this video. But we're going to take it piece by piece here, and got a lot of ground to cover. I'm going to try to keep this as brief as possible, but also as thorough as possible. So the first thing is, what he's talking about are ephemeris tables of the positions of the planets over time. And they are, any given ephemeris table is only going to be valid for the time period in which it is published. It's a list of coordinates of where each planet is, or it can even be for specific objects. It can even be for satellites. It's a general term. And obviously, even though Earth is going around the sun once a year, that doesn't mean all the other planets are going around at the same rate, right? So Venus and Mercury travel around the sun faster than we do, but it still takes them a while to lap Earth in orbit because we're not stationary. Conversely, Mars, Jupiter, Saturn, Uranus, Neptune, these planets all travel slower than the Earth relative to the sun. So from year to year, the planets will obviously be in different positions on a given date. You can't take an ephemeris table from one year and expect it to work the next year. That's never been the case. Now, in terms of calculating the orbits of those planets, yes, the orbital elements will continue to work over time. Perturbations do occur. The planets do have an effect on each other's gravity, and Over the course of human history, it's been a challenge for astronomers to accurately account for that. And around the late 19th century, an American astronomer, I believe actually he was born in Canada, but he was an American citizen as well, published a table of the elements of the planets and how they would evolve over time based on their mutual gravitation. And it was quite accurate. So Simon Newcomb's tables were used for almost 100 years as the gold standard of predicting the positions of the planets. And we're going to look at that tonight and see how accurate they still are today. But first of all, he cites a number of different sites, no pun intended. One of them you see here is clearly an astrology site, currentplanetarypositions.com, okay? So this is all about astrology here, and that's a key. That should send up a red flag, because it's not going to necessarily tell you accurate information about where these objects are in the actual sky. And we're going to get into why here in a minute. But first, let me play a little more of his video and see what else he has to say.
Of the planets, but they're saying they're caused by asteroids. So it's it's kind of a vague, and maybe somebody can shed more light on this, a vague reason why they're saying we need to update our ephemeris every year now. But the most common one used, issued by the powers that be, is the J2000. And
Okay, I'm sorry, I have to stop it there for a moment. He refers to J2000 as an ephemeris. This is demonstrating a fundamental ignorance of basic astronomy here. J2000 is not an ephemeris. It's epoch. What is that? Well, let's take a look here at Wikipedia, and you can find this cited in many different locations. I'm just using Wiki here for quick reference, but it's a reference epoch. That means it's a point in time that the coordinates are referenced to. This is particularly important with regard to precession. So J2000 refers to 12 p.m. on the 0th day of January 9. Sorry, that's actually J1900. J2000 is, where do they talk about it here? Let's see. Yeah, here we go. 2000, January 1st at 1200 terrestrial time. So that is the reference point for J2000. J standing for Julian, as in Julian years, 365.25 days on the Julian calendar. And there are other reference epochs that have been used throughout history as well, such as B1950, and he's going to mention that in a second in the video too. Again, these are not ephemeris tables. These are reference epochs for coordinates. So when somebody tells you these coordinates are J2000 coordinates, what they're saying is that those coordinates correspond to the position on the celestial sphere measured relative to Earth's orientation at this time. And that orientation changes over time, primarily due to precession. Now, precession does take about 26,000 years to complete a single cycle, but even at that rate, it is still large enough and important enough that even in going out a decade matters. You'll see a significant difference in the position given by J2000 coordinates versus coordinates at the epoch of date, for example. And that's because of precession. It's very important in astronomy to understand that. So if someone hands you a set of coordinates, unless you happen to be near the year 2000 and you can assume that the epoch of date is reasonably close to J2000, you ought to be asking, okay, what is the epoch of these coordinates if it's not explicitly stated? Because coordinates at the epoch of date are going to be different than coordinates at the epoch of, say, J2000, and especially, one of these older epochs like B1950. And B1950 refers to a different way of defining the year and the starting point of the year as being the point where the sun's mean the sun's position, mean longitude, relative to the equinox is 280 degrees. Anyway, this corresponds to just about January 1st. And so B1950 is very close to being January 1st, terrestrial time, 1950. So these reference epochs have changed over the course of, the last century, but that's because of precession. They get updated on average about every 50 years. In 2050, I'm sure we'll have another reference epoch. And then, of course, there's coordinates at the epoch of date. That means coordinates that are referenced to the orientation of the Earth right now. Today, if I give you coordinates and I say, these are the coordinates at the epoch of date, and I observed it tonight, that means it's relative to Earth's current orientation, as precession has changed it over the last 17 years. So we'll get into more of that in a second, but I want to play even more of his video here now. So keep in mind, when he says something like J2000 or B1950, these are epochs, not ephemeris tables. Ephemeris tables are lists of coordinates. Epochs are the points in time those coordinates are referenced to. There is a difference. Just because something is referenced at J2000 doesn't mean that the coordinates at that point in time, though. So I can give you J2000 coordinates, for example, of where the moon is tonight. And what that means is you can think of it sort of like if there had been no precession over the last 17 years and Earth's orientation was exactly the same as where it was in the year 2000, that's what you would see in terms of where the moon is in the sky. It's just a different way of referencing the coordinates. If I give you coordinates to the epoch of date, the whole orientation system of the equatorial grid is going to be different than if you give you coordinates in J2000 format. And either one is valid. Both are used by astronomers. It just depends on what's most convenient. So let's play some more of his video here, keeping that that problem in mind, and see what else he has to say.
There's also a J1900 and a B1950, and we've gone back and looked at all of these because the planets aren't really supposed to change. And basically they're saying that they're upgrading annually because the asteroids are an unknown, secular unknown, that are affecting the planets. And if anything, it's the planets affecting the asteroids. But I'm not sure if that's a misstatement in some of the literature or not. But nonetheless, anybody who has a go-to telescope has had a fit using any of the old software to find star clusters in the specific stars. And if you call the helpline, they will update your telescope. So
Oh boy, how many times have I heard that claim? No, I'm sorry, that is completely wrong. Software in modern telescopes is occasionally updated because of two major things: bugs in the software that need to be squashed, or they're updating the orbital elements of comets and asteroids and adding new comets and asteroids and satellites as they're discovered or launched or what have you. The software in my telescope, however, has not been updated ever since I've had it. And I've had it a long time now. In fact, it can't be updated. You can't hack the software in my telescope because it's hard-coded on memory chips that cannot be altered without physically removing them from the motherboard. The telescope I have is the LX200 Classic, not the GPS, not AutoStar. This has the old Magellan computer system. And in that computer system, there was no provision at all for updating the software by the user. To update the software, they had to physically remove the motherboard, and you had to ship that back to the manufacturer, and they had to put new memory chips on it. That was the only way to update the software. And it hasn't been updated in decades now. So if this claim is true, the LX200 should definitely not be working, because it is basically one of the oldest types of go-to consumer-grade telescopes out there. There were one or two other odd little go-to telescopes that existed before the LX200, but none gained any popularity. The LX200 was the first really popular consumer-grade go-to telescope. It's been around since before any of the Next Stars, any of the new LX200s or the LX90s or any of those telescopes, ETX, you name it. And it still works even today. So here was a webcast I did all about the winged star on Google Sky, and you can go check this video out if you want. But what I really want to show you here is how well it really does work. So I have in view here, obviously, the moon, a crescent moon, and in just a few seconds in this video, I tell the telescope to slew to Venus. And guess what? It worked. So I didn't need to call it meat and complain because it's no longer working. No, it worked fine. So let me switch the audio here again, just so you can hear the telescope whizzing by in the background. You'll hear the motors kick on just a couple seconds after I start this video. Let me expand this. Here we go.
Beautiful. So, it was a morning quite like this one.
So that was the LX200 telescope doing its thing. Slew to Venus just fine, and it still does even today. I don't know, it was just a few days ago I did some observing with it, and it was still working just fine. So I haven't had to freak out about that, because it would be a major problem if it did stop working all of a sudden, because I can't update that software. No one's writing any updates for that software, and the only way I could update it is to physically remove the motherboard, remove the memory chips, and replace them. And that would be a major pain. So fortunately, I don't have to do that. But we're going to get into more about this and actually see whether or not Venus is where it should be. But first of all, let's finish up here. I'm going to go a few more seconds into this video so that we can see one of the sites he's complaining about, which he says the coordinates are all wrong.
Well, they're having to update the position of planets and stars annually now, which should be kind of like a little light bulb going off. But in the recent times, astrologers use ephemeris to calculate transits and positions as well. But the Farmer's Almanac goes back way back using an old almanac, and Farmer's Almanac does not match the positions given by J2000.
Okay, a couple of important points here. First of all, you heard him mention the word astrologer there, didn't you? And that's no lie. This is an astrology website right here. Now, that's a problem. That's a big problem. That's a big goof. Also, he mentions the Farmer's Almanac, and he says it doesn't match the positions given by J2000. Okay, no duh. First of all, we need to remember once again that J2000 refers to an epoch, right? Nobody was using the J2000 epoch back when the old Farmer's Almanacs were published, say, back in the 19th century. No one was using J2000. Those coordinates were generally listed at basically the epoch of date, if they even gave coordinates. The Farmer's Almanacs usually just gave like rising and setting times. But in terms of comparing them to other ephemeris, they still work, but there's a catch there. Farmer's Almanacs, let's say you look up a Farmer's Almanac from, say, the year 1850. You know what didn't exist in the year 1850? Time zones. Nobody had time zones. Everything was referenced relative to where the sun was in the sky. Sundials, right? If you look at time and measure it with a sundial, it's not going to match up with your watch that is set to, the local time zone. And the difference between what we call mean solar time, you can think of it as sort of the 24-hour day and the fictitious sun, because the sun doesn't move at an even rate through the sky, because Earth's orbit is not perfectly circular, etc. But you can think of mean solar time as the 24-hour day and sort of this fictitious somewhere that we just sort of take an average of the sun's motion. And you can think of that as your local time zone. The difference between that and real solar time, the actual sun, if you were to measure time by a sundial and that kind of time, the way things used to be done in 1850, the difference between those two values is called the equation of time. So we can calculate how far apart the times given on an old farmer's almanac are compared to modern time using mean solar time and time zones. You know, you have to do the calculation for your time zone relative to GMT to see, you know, how far or where these objects should be according to calculations based on their orbital elements. But we're going to get into that in just a minute. First of all, this website right here showing where these objects are, which constellations they're in, right? This does appear to be wrong if you look at it. Let's see here. Let's pull up, let's see, what do we got here? Let's pull up my spreadsheet here. This is my Sun, Venus, and Moon calculations spreadsheet, which I've already put the link in the video description here. You can download it right here. This is the same spreadsheet I gave out back in November, or was it early December? Anyway, I recorded the pictures in November of Venus and astrometrically solved the picture, showed you guys that it really was Venus based on what calculations of its orbit say. Calculations that predate the existence of NASA, by the way. I'll show you that in a minute too. But I put the spreadsheet up here on Drop Canvas, and I dropped that link in the video description of this video as well as the November video. So if we pull up that spreadsheet, very handy, it gives us the coordinates both at the equinox of date and at J2000. So remember, these are the reference epochs for the coordinates. These coordinates here on the left are at the epoch of date, meaning precession as it is now, versus the J2000 reference epoch. So let's see here. Let's just take the sun as an example. So here are the J2000 and the coordinates at the epoch of date of the sun. And let's see, he gives this page here is January 22nd at 9:49. And topocentric parallax isn't going to much matter here because the sun is, you know, an astronomical unit away. At that distance, it's not going to matter enough to put it in a different constellation. So let's see what constellation it should have been in. The constellation we expect it to have been in. Let's see here. Where is it? Here we go. So this is a handy little website right here. You can just pop in your coordinates, and it will tell you which constellation those coordinates correspond to. So let's take the J2000 coordinates of the sun here at that time, predicted by my spreadsheet. 20 hours, 18 minutes, 25 seconds, negative 19 degrees, 38 minutes, 12 seconds. Find constellation. Where'd my mouse go? Find constellation. Says it should be in Capricorn. Says here, Aquarius. Uh-oh. Uh-oh, SpaghettiOs. So does that mean that the sun's actually in Aquarius and they had to change this website to reflect the fact that the sun's actually in Aquarius? Let's try Venus real quick. Let's look at Venus. So it says Venus is in Pisces. Let's try that one, see if that one adds up. So same point in time. That hasn't changed, but we just need to find out where Venus is. So here's the J2000 coordinates for Venus. And we've got our handy little constellation thing over here. This website expects them in J2000 coordinates. Why? Because this is kind of why you use a reference epoch. You don't have to tell it when the observation occurred. That doesn't have to be a factor. If I tell you these are at equinox of date, you have to know what the date of the observation was to know what the what precession looked like on that date. But at J2000, it's a reference epoch, so we can just enter the coordinates in J2000. So 23 hours, 19 minutes, 8.8, negative 3 degrees, 49 minutes, 36.75, declination. Find constellation. Aquarius. Oh, wait a minute. Come back to the site. It says Venus should be in Pisces. My goodness, that's wrong too. So why are these all wrong? Well, this is an astrology website. And astrology sites like this don't take into account precession at all, and they haven't for a very, very long time. So there's a whole variety of articles on this in the mainstream media, and you'll see this occasionally. This whole story will get recycled every couple of years, it seems. So it comes back up again, and it came up, gosh, this was from 2007, but you can find more recent articles. I know it's been recycled since 2007. So, astrology, why your zodiac sign and horoscope are wrong. And basically, they go through here and they tell you the fact that astrology, Western astrology like this, doesn't take into account precession. And so the zodiac sign that the sun was supposedly in on your birthday is wrong. Or at least in terms of the constellation, that's not what constellation it was actually in. That's not what constellation these objects are in, because it's not accounting for precession. And so if you look up your zodiac sign, according to this article, now I don't know enough about astrology to say exactly what epoch essentially this would correspond to. When did they stop accounting for precession? I don't know the date. I'm not an astrologer, but if you see these stories in the media, they frequently tell you it's basically where the constellations were more than 2,000 years ago. And that sounds about right. I mean, it's way off. I know that much. Like we just saw, the sun's not in Aquarius. Venus isn't in Pisces right at this point in time. It's just wrong. And it's probably not even that the website is broken per se. This is probably, I'm guessing, what an astrologer would tell you, this planet is in. But the zodiacs, I know it's ridiculous, but to me it's ridiculous anyway. I am not into astrology at all, full disclosure. But they would say the zodiac sign is not the same as the constellation, so you can't compare the two. Just because your astrologer tells you that Venus is in Pisces doesn't mean Venus is actually in Pisces or anywhere near it in terms of where it is in the sky. So you have a fundamental misunderstanding here again, where Higher Truth Channel is using astrology sites as if they are accurate for astronomy. Astronomy, astrology, two very different things. And so clearly this site is not accurately reflecting where the planets are predicted to be, even according to my spreadsheet, which again, where does my spreadsheet come from? Well, the calculations come from Newcomb's tables in the late 19th century. I mean, these calculations are over 100 years old at this point. So briefly, here is my video describing the spreadsheet when I first published it, with these highly accurate calculations for where Venus actually is relative to Earth and for an observer on the Earth. And I showed a scan of the sheet that I pulled, these numbers from. And where do these numbers originally come from? Well, right here we have the orbital elements, and we have a series of coefficients. And these coefficients get plugged into equations for calculating the orbital elements, the mean orbital elements over time. So where do these numbers come from? Well, they actually come from a book that was published in the late 19th century. So here, for example, for Venus, let's see, 342 degrees mean longitude. Let's see, let's come back here. Does that look familiar? Yeah, same number. Eccentricity, let's just take a look at some coefficients here. So eccentricity, let's see, Venus, can't read. Eccentricity 0.000047 ... Yeah, same coefficient there. Inclination 3.393 degrees. Inclination to ecliptic. It's given here in sexagemal coordinates, 3 degrees, 23 minutes, 37 arcseconds. If you convert this to decimal degrees, you'll find it matches up. So this is where these orbital elements come from. And T is time from the epoch of the elements. And so you plug this in, you plug in the date, how far you are from the reference epoch of these elements, and you get the mean elements at your equinox of date. And you go through and you do your calculations based on the orbital elements, and you account for the perturbations. Yes, that was given as well. And even back in the 19th century, they knew how to account for that. And guess what? It still works, even today. So, and I do mean today. So I took a picture tonight of Venus, that bright planet you see in the southwest or west-southwest after sunset. In fact, if you are keen-eyed, you can even see it before sunset. You can even see it in broad daylight. It's that bright, if you know exactly where to look. It's a little tricky the earlier in the day you do it, but as long as Venus is well above the horizon, yeah, you can see it in broad daylight. So here's the astrometry on the photograph that I took. And I pulled this into SAO image DS9 to read out the coordinates. So we have all these nice stars here. This allows us to determine the coordinates of every single pixel in the image. So we can take the same spreadsheet here, which calculates the position of Venus. We can plug in the date, time, and location of when and where that photo was taken. I'm going to paste that in here and scroll down here. And now we're going to use the J2000 coordinates, again, J2000 being the reference epoch, and plug that into SAO image DS9 for the coordinates of Venus here. You can see it's a match with the coordinates in the spreadsheet. And guess what? That shows the green circle here. So these coordinates that I've plugged in here determine where this green circle shows up in the image. And guess what? It matches the position of the super bright object. This really is Venus. And the spreadsheet predicts it. And the spreadsheet is based on calculations that go back more than a century. Way older than my telescope, way older than even the existence of NASA. And needing an update to fix it because it's no longer working. That's just not the case. It really is working. Venus really is at the coordinates that this spreadsheet says it's in. And it's not, it's not where that astrology site said it is. It really is in the constellation. Well, actually, is this right? Let me update this. Just see. What is it in tonight? 23, 27, 32.77. Let's round that up to 7, 8. Oh, why is my number key off? 7, 8, -2, 35, 8.2. So, yeah, it's still, nope, now it's in Pisces. So now Venus has moved into Pisces. But back on the 22nd, as we saw earlier, it was in Aquarius. So it's now transitioned into Pisces, but it's now January 24th, not January 22nd. But you get the idea. That astrology site was not consistent with the current position of Venus, because, or at least the position of Venus as it was said at that time, because they're not accounting for precession properly. Now, he also mentioned the Farmer's Almanac, and I do want to go into that. So here's a scan of a Farmer's Almanac from the year 1850. And if you remember what I said earlier, they didn't have time zones in 1850. They used the sun as the measurement of time. And so we have to use real solar time, not mean solar time, when looking at these numbers. And so, as you can see here, this is the symbol for Venus. And that's, when you see the symbol, that means they're giving you information about Venus. And this is January 1st, 1850, and as viewed from about Philadelphia. So 1850, January 1st, Philadelphia, Venus should rise at about 6:26. And again, that's solar time, not Eastern time per se. So how do we calculate that? So the equation for the equation of time is actually pretty simple. And I've got that in this handy book over here. You can find this in a variety of old astronomy textbooks. The one I have and like is Practical Astronomy with Your Calculator. And on page 98 of the third edition, you'll find the equation of time. And it's simply to calculate the right ascension of the sun, which I already have from the spreadsheet. Then you convert that to decimal hours. Take it as GST and convert it to UT, subtract this from 12 and convert it to hours, minutes, seconds, and that is your equation of time. So pretty simple method, pretty simple process. And doing that, we find that at 1850, in the year 1850, on January, and this should be January 1st at 6:26. So that's going to be 11, 2. We have a equation of time answer of 3 minutes and 49 seconds. So keep in mind here, oh shoot, I lost my page. Where's the equation of time? Here we go. Keeping in mind that the equation of time is given in this book is taken as mean solar time minus real solar time. That negative number means that real solar time is a larger number than mean solar time. So basically, we have to keep that in mind. And so mean solar time is what we're plugging into the spreadsheet effectively. And we have to take back 3 minutes and 49 seconds to get to real solar time. So that's our conversion factor on this, basically. So if we come in here and we plug in, let's plug in 11. So we're going to be about 5 hours from the time zone of universal time here to get to the eastern seaboard. And then we account for the fact that there's about a 3.5 minute difference between, actually it's like 3 3/4 difference, almost 4 minutes of difference between mean solar time and real solar time. Let's just take that as 4 minutes there. We find that Venus is on the horizon at 0.2 degrees. So yeah, Venus is rising at that time, just as the Farmer's Almanac says it should for Philadelphia at that time. So Venus is in the southeast and rising at the time given in the Farmer's Almanac. It still works. So we've got that. Also, we can take a quick look here. It says Moon's place. This little symbol right here, that funny looking symbol, that's for Leo, the lion. And so it's saying that on that date, the moon should be in Leo, the lion. So once again, we can take our spreadsheet here. We can get the coordinates for the moon and plug that into our constellation finder. Let's see. Am I pulling the right coordinates? Yep. 9 hours, 40 minutes, 14.1 seconds. Degrees, 55 minutes, 55 seconds. Oh, sorry, I gotta have the symbol in there. Constellation, Leo. It's a match. So yes, the Farmer's Almanac from 1850 agrees with my spreadsheet, as do modern observations of Venus. So Venus in the photograph taken tonight matches the coordinates predicted by these old equations that date back over 100 years. And it also matches the Farmer's Almanac from 1850. So it's all in line. It all adds up. Basically, the conclusion here is that the orbits of the planets do not appear to be disturbed. They're not in the wrong constellations. It's just that astrology websites are not going to accurately tell you where these objects actually are in the real sky, because those astrologers aren't taking into account precession. And they have their own rationale for why they don't take into account precession. And some of them would tell you they don't want to take into account precession. That's not what they're interested in. They don't care where the stars actually are. That's their business. I'm not an astrologer. I'm not going to argue that with them. But what I'm telling you is you can't use those sites as an astronomy reference. Astrology and astronomy are two very different things, and you do have to account for precession. And part of accounting for a precession means knowing what the epoch of the coordinates are, and it's not the same as an ephemeris table. An ephemeris table would be if I plugged in, say, one day after the other into my spreadsheet, and I read out the series of coordinates for Venus or whatever, and I put that into a table. That would be an ephemeris table. That's not the same as J2000 or B1950. Those are epochs to which those coordinates are referenced. So I think that covers everything. I know that was a lot to take in. I hope that all makes sense to you guys. Hope I didn't go too far over everyone's heads. I want to see here. I haven't been able to pay attention to chat here while I've been doing all this. I'm running solo tonight, so let me grab the chat here real quick and see what your questions might be. Pop out chat. So let's see here. Okay. Sorry, I'm trying to get my windows rearranged here so I can see what everyone's saying. I have a lot of Venus brightness questions. Okay, thanks, Gypsy. So that has been, I've addressed that like 9 ways to Sunday now, but the last few videos I've done have addressed that as a matter of fact. Let's see here. Let me see if I can pull up one of those videos. And, you know, I should probably just drop the link in the video description. I mean, if you guys want to talk about that, I just did a webcast on that last time. So the last hangout I did was actually all about the brightness of Venus. And so, you know, there's a couple ways of skinning that cat in terms of trying to accurately measure the brightness of Venus. Let's see here. Let me put this thing back on sharing my screen. Okay. So there's old me from the previous webcast. So this was January 20th. I did this webcast. And we covered the brightness of Venus. Let's see. And in that video, I was presenting data of the brightness of Venus relative to Sirius, which is the brightest star in the night sky. But Venus is even brighter than the brightest star in the night sky. In fact, it's the brightest object after the moon. And so it is incredibly bright right now. But that's expected. It's exactly what it should be. And once again, you know, in these videos, I was referencing equations that go back before the existence of NASA. And they still work today. And that works whether you're measuring it relative to a star or relative to another solar system object like the moon. So originally, I did a video. When did I do that video? January 2nd. So I did this video back on January 2nd where I measured the brightness of Venus relative to the moon. And, oh, hey, it's an ad for my own webcast. That's kind of meta. But back on January 2nd, I did this video, Is Venus Brighter Than Normal? And really, you know, back at that time, a lot of the videos I was doing was just trying to simply identify it because a lot of people didn't believe that it was Venus. And, you know, I'm sure a lot of people still aren't going to believe me when I say it's Venus, but that's what it is. So, you know, a large part of this was just proving that it was no brighter than Venus is supposed to be. And a lot of people I was seeing were suggesting that it was too bright relative to what they had seen Venus, relative to the brightness they were accustomed to Venus being relative to the moon. Does that all make sense? So initially, I just, as a quick and dirty thing, measured it relative to the moon because it was right next to the moon, and it made it awfully convenient to take a picture of both of them at the same time and do that measurement. And sure enough, it came out that Venus was exactly the brightness it was supposed to be. But that got attacked because I was measuring it relative to another solar system object. And a totally different series of claims was that every object in the solar system is getting brighter. Okay, fine. If that's the claim, then these objects should also be abnormally bright relative to stars, distant stars like Sirius. So that's what my last webcast was all about. So to get back to the question, if you want to see whether Venus is too bright or not, I recommend you go check out my video back here from January 20th, live discussion of the brightness of Venus, where I addressed that pretty thoroughly. So I don't want to rehash all that again because I spent an hour that night doing that. So please go check out that video, and if you have any other questions, feel free to leave them. So let's see. Okay, so Diamond Dog asks what that part of Google sky that was blacked out near Orion was. I've got a video about that too. Geez, I've got videos about everything, don't I? Not everything, but I've got videos about a lot of commonly asked questions. I should just make like a video of my videos, a video like doing a quick rundown of the most frequently asked questions, like a frequently asked question video. So mysteries. Let's pull this up real quick. Here it is. I'm particularly proud of this one because I did a lot of legwork on this video. This was an in-depth investigation of the missing section of Google Sky. There's a section near Orion in Google Sky which has been missing basically forever, as far as I can tell, since Google Sky has existed. However, the actual picture that is literally missing here is available a variety of ways. And I did an investigation where I took my own pictures of that section of sky with my own telescope and compared it to digital scans of the section of that section of the sky, which you can find from the Palomar Sky Survey sites, where you can go and download the raw data. Google Sky is not raw data for anything. They're just taking pre-existing sky surveys and stitching them into a single global mosaic, which they use in Google Sky. They didn't set out their own telescopes and take these pictures. They just used what was already out there. And in this case, it's from the Digitized Sky Survey, DSS, which is essentially a digitization of the Palomar Sky Survey, POS 1 and POS 2. And most of these images are coming from POS 2. So here's my telescope's image of those stars. And then I compared that to the digitized version. Found something that was present in the blue plate specifically. So there's, I have to cover that too, basically. The Palomar Sky Survey was conducted with film plates, and those film plates were monochromatic, black and white, grayscale. And each film plate was sensitive to a particular portion of the spectrum. And on the blue sensitive film plate, you had this spot here, which did not seem to be corresponding to any object that was currently present at those coordinates in my image. And so I tracked down the actual film plate, or the actual photograph that was missing, that blue photograph specifically, and located it at a university in Ohio where you can actually view the original negative, and looked at that and looked at the missing section. So this is from the actual, negative from that section of Google Sky, and it actually covers a much larger region than just the missing section. So I did a quick photo of that. I had to use an LCD monitor as a backlight because they didn't have one available at that library. They weren't really properly equipped to view these negatives the right way. I should have brought my own light box, but I didn't know I was going to have to do that. So I improvised with an LCD panel, which is why you see sort of this mesh work here, the pixels on the LCD panel. Anyway, inverted that negative into a positive and overlaid it back on top of Google Sky. So this is from the actual photo negative, and that spot's not there. So what does that mean? That means that spot, which is the exact same photograph, only I looked at the actual original negative, that spot's not there on the negative. That means that spot was some piece of dust or dirt or debris when the negative was scanned originally that ended up in the digitized version. And that's why you see this bright blue spot, because these are negatives. And so when you scan this negative, any dust or debris that's in the scan is going to look bright when you invert it into a positive. So that's why that anomaly was there. But that was the only anomaly I could find in that region of the sky. So other than that, there was nothing of interest there. It was an interesting mystery, but it wasn't anything, it wasn't Nibiru or anything like that. Okay. So let's see. That was probably a longer answer than you wanted, but if you want to see more, check out my video here from a couple years ago, Google Sky Mysteries, The Missing Sky. Let's see. What other questions do we have? 2017 BX. That is a newly found asteroid. It's a near-Earth asteroid. Is that passing by tonight or tomorrow night? I don't know. It's passing by sometime soon. It's a tiny little dinky thing. It's like somewhere in the 5 to 15 meter range, I think, in terms of size. Really small, and it gets no closer than about 0.6 or 0.6 times the distance to the moon. Easily observable. It only gets as bright as about magnitude 17. For reference, the dimmest the human eye can see is about magnitude 7 if you're really, really good. magnitude 17 is dimmer than the central star in the Ring Nebula, if memory serves. So it's really, really dim. Not really easily visible. I don't know the coordinates right now off the top of my head. You could find that on JPL's site or off the Minor Planet Center website. But trying to observe it, really tricky. It's really not worth the effort unless you're actually trying to do some real scientific measurements of its position to keep track of it, to submit to the Minor Planet Center, which is very important. You know, a lot of amateur astronomers get into that, and it's a very important service. Because the professionals, you know, they find these new asteroids like that, but they don't have time to keep following them day after day after day. They'll just keep looking for new objects and leave it up to the amateurs, the amateur astronomers, to track these objects and keep following them so that we continue to have fresh data on where they are. You have to collect data over a period of time to refine the orbit determination. And Scott Manley has a great video about that, how asteroids are discovered and how their orbits are refined over time. So unless you're doing that, though, it's just not worth it for a magnitude 17 asteroid. I'm sorry to say. It would be a pretty miserable webcast if I were to do that. I usually only do them once they get to about magnitude 15 or brighter. What else do we have? You know what? For this final part, let me go ahead and drop the link to the Hangout. So if you guys want to join the Hangout, if anyone wants to join the Hangout and come on here live with me and ask questions, if you have any pressing issues, feel free to join. So if we have any issues here with any disruptors coming on here and trying to disrupt the webcast, I'll just cut the video here and re-upload the first section. And that's how we'll deal with that, because occasionally I've been on other channels where we've done this sort of thing and it doesn't always work out so well. But if people want to try to do that, I'll just cut this section. So if you're seeing this video and this is where it ends, that's why. But if anyone wants to come on and ask some questions on the mic, there you go. There's the link. I've dropped it in the video chat here. Close comet pass. Yes. Yes, there is a close comet pass coming up. And so here's a website I highly recommend. Boy, I can't spell right now. I'm running on very little sleep today. But Aerith.net, not to be confused with Final Fantasy, shows weekly information about upcoming bright comets. And this is the comet of the hour. This is the one everyone's excited for because it does get pretty close to Earth. And it's 45P, comet 45P, and you can find charts of its position over time here. Now, it's really not going to be easily visible till you get into about next month. Early to mid next month is when it gets to be its best. And notice how much it moves from night to night as it gets closer to Earth. You can see how the spacing between these dots become farther apart. They're about 5 days apart or so, and around here the spacing's really wide because it's really close to Earth and it's flying by quite fast. So, and even then by quite fast I mean, I don't know, a few arc seconds per second maybe. I don't know. I'd have to look at the exact numbers. To a telescope, it's pretty fast, and you have to do something active to keep up with it. By eye, you wouldn't really notice it moving all that much if you can spot it, but it is pretty dim by eye. It's peaking here around magnitude 7 or so. So you remember what I said a moment ago. Magnitude 7 is about the limit of human vision. So it's not really, really super bright, and this red line shows the predicted magnitude over the pass. It is a little bit brighter than expected, which is nice. Almost peaking up to about magnitude 6, but that's still really hard to see. You have to be under pristine dark skies using averted vision to be able to spot this little fuzz ball in the sky. If you really want a good shot at seeing it, get a pair of binoculars and look for it. That's going to be your best shot. And for close finder charts, if you don't have Stellarium, well, get Stellarium. But if you don't want to install any software on your computer, the website I recommend for close finder charts is heavensabove.com. Very handy site for tracking satellites and also comets. So if you go to astronomy and you click on comets, they have this handy site right here, 45P. And here you go. Here's some close finder charts. So you can find it with binoculars pretty easy here. Just keep in mind, north should be up in this image, And depending on where you're looking over the horizon, you may be experiencing some field rotation relative to what these finder charts show. So you have to have a little bit of experience in terms of knowing how to star hop sometimes with this, but this will help you. The thing is, right now it's not easily visible because notice here's where the sun is right now, and the comet is not very far from that in the sky, so it's not really readily visible right now. As it gets into next month, it'll become a lot easier for me to observe. So I do plan to do a webcast on that and do some tracking on it and show you guys that comet. Hopefully it'll work with my tracking software that I'm developing, which does have a minor planet tracking function. So we'll try that out and see how it works. Looking forward to it. So sometime around middle of February, I plan to do that that webcast. Why is Sirius A blocked out on every image? Well, it's not. I know there are Palomar Sky Survey images where it is blocked, but it's not blocked out on every image. So let's see. POS, DSS. Is this the one? No, that's not the one I like. This is the one I like. So if we come in here and you type in Sirius, get coordinates. Let's do 60, 60. This is how you download. This is one way you can download some of the raw images, the raw scans from the digitized sky survey of the Palomar Sky Survey images. And this will let you see stuff like this. So if we download POS2 red plate, so remember, these are monochromatic film plates at a variety of different wavelengths. Oh dear, it's blocked. But if we come down to POS1 red plate, and we download that one, it's not blocked, but there's a lot more glare. Notice a lot more stars are washed out by the bright glare of Sirius. So sometimes it's helpful to occult the object so that you can detect more stars closer to Sirius in these long exposures. You know, these were taken with film plates that had very long exposures, and this was you know, an all-sky survey designed to detect all these different stars, and it was really kind of tricky to detect stars this close to Sirius because these were long exposures. So that's why that happens sometimes. In newer sky surveys, now that everything's gone all digital, sometimes you'll just get, you know, strange artifacting in the image if a star's super bright and it blows out the detector. But they're not blocked. It's not blocked on all the images. You can get unblocked images of Sirius just fine. So there's the POS1 red plate. Here's the POS1 blue plate, and you can see it on there too, unblocked. Dot, dot, dot. Here comes POS1. Now the problem with Google Sky though is that you can't select that. They don't give you that option. They just picked whatever they felt like picking and put it into their all sky mosaic. So you need to go to the original source, which is not Google Sky. That's why I say no serious researcher uses Google Sky to access the original Sky Survey images, because it's not a primary source for any Sky Survey images. You need to go to the original source, the horse's mouth, as it were, to get these images to pick the ones you want, because sometimes the ones they pick on Google Sky don't make any sense. Another example of that would be, let's see, would be Saturn in the IRAS images. So Skyview Virtual Observatory. This is a handy site for quickly accessing, I wouldn't call this raw data, but at least semi-raw data, better data than Google Sky, of many different sky surveys all at once. So, oh, shoot. What were the coordinates of that? Oh, shoot. I'm going to have to look it up real quick here. Saturn, IRAS, 1983. Coordinates. Somewhere. Okay, well, actually, they've got a whole blog about it here. This will make life easier for me. Well, Skyview actually has a blog entry all about this. How handy. So a lot of people ask questions about this. So if you look on Google Sky, what you're going to see is actually this censored image right here. And this gets a lot of questions too. So if you look at the infrared layer of Google Sky and you look over at a particular portion of the sky, I think it's near Leo, but I'm not sure. Well, okay, here's the coordinates. There you go, right there. If you look at those coordinates in Google Sky in the infrared layer, you're going to come across this block right here. And that's because Google Sky chose foolishly to use the IRIS reprocessed images from the IRAS telescope. The original IRAS images are not censored like that. You can see this double thing right here. This is actually Saturn, a double image of Saturn that was recorded on at 2 different points in time by the IRAS telescope. The IRAS telescope is a far infrared all-sky survey, and it used cryogenic coolant to keep the detector cool. And that coolant was boiling off from the moment it was launched. So they were on the clock. They had 1 year to cover the entire sky. And because they were on such a short time schedule, there wasn't time to come back next year or the year after and cover these same coordinates again when Saturn was not present. So Saturn ended up showing up in the IRAS images, and it is this bright source here. The same thing actually happened to the WISE images as well, because it's the same story. The WISE telescope is another wide field infrared survey explorer. That's what WISE stands for. It used cryogenic coolant. Oh, Chu's joining us. All right, hang on a second, Chu. I'm going to mute you for a second here, just so I can finish my thought. Why isn't this working? I can't seem to mute him. That's weird. Anyway, what was I saying? The WISE telescope also had this coolant limitation. And so Jupiter showed up in the WISE images for the same reason, because they couldn't come back a year later when Jupiter wasn't there. And as a result, it forms a really bright image there. So if you go to one of my recent videos, I actually talked about this, and we covered the images from the WISE telescope showing Jupiter. Let me see here. Pull up that link. And there was a book published recently by David Mead claiming that it was Nibiru, but it's really just Jupiter. So that's covered in this video here. Nibiru arrived in October 2017. And it's all about that book, which is actually all about Jupiter and the WISE images. So January 9th webcast I did. You can see it. We talked all about this. So that's what that's all about. All right. So sorry, Chu. You were joining here. He dropped out. Well, Chu, if you want to join back in, I'll be happy to field any questions you might have or any issues. Let's see. All right. Well, I don't really see too much more in the way of questions at the moment. All right. Anyone else have any questions here before I wrap it up? What happened to my hair? I don't know. I guess I like my new hairstyle. Some people not so hot on it, but I think it looks nice. I don't know. I used to have this crazy spiky hair, but trying to go with a more professional look these days, I guess. Maybe a bit retro, but a little more professional, perhaps. Here's an interesting question. So one more question here. Let Sleeping Dogs Lie asks, this year started with a new moon in the beginning of January or beginning of the year, and by mid-January, the moon was full. Is that normal? Yes. You can, just as a rule of thumb, think of it this way. This is just very approximate here, but if the moon is, say, a new moon phase, 1 week later, it should reach first quarter. And the first quarter phase means it's half full and waxing. 2 weeks after new moon, you will have full moon. And then 2 weeks after that, you'll have another new moon. So, yeah, that's quite normal. Oh, brother. Double Cross Swine says, I need a special lady. I already have a special lady, but thank you. All right, we got a couple people joining here. Factard and Chew. All right, Factard. Well, it looks like you got your mic on. So, you have anything you want to ask?
No, I'm just, this is my first time ever in the Hangout, so just checking it out.
All right. Chew, do you have any questions you want to ask?
Yeah, I didn't see you on the Vortex discussion about this. Just wondering if you heard it on Nutcrackers.
No. Well, I'm not on Vortex anymore. I had to abandon ship there because of a certain stalker who shall go unnamed in this hangout. Yeah, no.
I quit Vortex back in October. And
Uh-oh. I think Chew dropped out there. Yeah, so if
break.
Oh, okay. There you go. Yeah, sorry. I don't know if I'm lagging out or you're lagging out, but you had like a 30-second gap there.
Yeah, it's probably my laptop. It's an old jalopy.
Oh, okay.
Over 2 years old.
So I'm sorry. I should know this, but is this Chewbird actually? Is that who this is?
Yeah.
Oh, okay, cool. Good to see you, man. All right. Well, I was just about to wrap it up here. If we don't have any takers for questions, I was thinking. I was trying to invite what was his name? Cake. I think he went by like Cake A or something. He was hounding me about this earlier today, asking about this video that Higher Truth Channel put up. I thought he'd come in here and be defending Higher Truth Channel. I invited him to come join the hangout, but I don't see him here in the comments. And yeah, I'll drop the link one more time before I wrap it up here, just in case he's lurking. But I don't think he's in here.
Yeah. I just happened to just check my subscription and saw that you were live, so I thought I'd watch, of course, and I didn't see the intro, so I don't know if you discussed the difference between tropical astrology and sidereal astrology. And
no, I did. Well, I mean, I kind of in a roundabout way talked about Western, what I called it Western astrology, but a lot of Western astrology not accounting for precession. But I that's what you're getting. I mean, that's the more technical way of putting it. I was just trying to. Yeah, I was just trying to describe to people.
Yeah, like I said, I showed up late, so I don't know if you addressed it, but I thought I'd just bring it up. But yeah, it's what, 25? They haven't updated their dates in 2,500 years.
Yeah, something like that. And like I said, I don't actually know enough about astrology to say exactly what that date is. Like, how out of date are they? I just know they're way out of date. I'm not an astrologer by any means, but I do know that, they're not accounting for precession here. So, like I was saying earlier, you'll see these articles get regurgitated every once in a while about your zodiac sign being wrong because they're not accounting for precession. And then the Western astrologers pipe up and they say, well, we don't want to account for precession. We don't care where the stars are.
We don't care whatever. We don't care how our charts don't match reality.
Exactly.
Yeah.
And then it leads to, mass confusion here when, channels like this say, look, something's wrong with the orbits of the planets because these charts aren't matching up with these other charts. Yeah, because you're comparing astrology charts to astronomy charts, or you're comparing astronomy tables to astrology tables.
Yeah. It was like a couple years ago, they had that stupid article about you may actually be an Ophiuchian. Like, no.
Yes.
That's an astronomical zodiac. It's got nothing to do with astrology.
Yeah, that's something. I mean, that's a whole nother topic of for another night, I guess. I mean, yeah, you can get into that. So there's a 13th zodiac sign. I don't know. Like,
there is based upon IAU's 88 constellations that were adopted in the 1880s, but it's got nothing to do with astrology, where the zodiac signs are evenly broken up into 30-degree segments. That's not how astronomers lop off the constellations.
Exactly. And, every time that story comes up, there will inevitably be somebody who claims that this is because the Earth has shifted and suddenly the ecliptic runs through Ophiuchus, or however you pronounce it. And no, it always has. Like, that's not new. Like you said, this is based on the way that the borders of the constellations have been adopted for 100 years now.
Well, the trivia about the Scorpion.
What's that? Oh, you mean about Orion and the Scorpion, or?
No, just Scorpius. Scorpius used to be a big ass constellation.
Oh yeah.
But they split it into two. You got Scorpius and Libra.
And Libra,
the two brightest stars on Libra translate to the Northern Claw and the Southern Claw.
Oh yeah.
So the modern day Scorpius doesn't have any claws.
Yep, exactly. It got declawed. So, yeah. So I think that's covered a huge amount of ground. If nobody else has any more questions, I'm just going to wrap it up for the night here, because it's now past midnight where I'm at, and I didn't get much sleep last night as it was. So I do plan to be doing just some I guess housekeeping information. I do plan to be tracking that comet everyone's excited about, 45P Honda. That'll be a couple weeks from now in mid-February, and then before that point, I've got a couple other things I'm keen on doing in the very near future. One of which is doing some demonstration of the software I've been developing. I know I did a little demo with that video tracking software I've been developing, but I'm going to do another demo this time showing some satellite tracking functions that I think are going to be kind of cool for people to have. And in addition to that, there's something I'm forgetting. What am I forgetting? I'm on way too much awakeness, not enough sleepiness lately. So, but there's something else I'm forgetting. But yeah, there's gonna be some more telescopic based webcasts I'm gonna be doing in the near future. So stay tuned.
That'd be great.
If you're new to the channel, please subscribe for more and like the video. All right. Well, thanks, Chu, and thanks, Factard, for joining me briefly here. And I'll be seeing you guys around. All right.
You bet.
All right.
Good night.
See ya.
All right.